Hello guys, welcome to the channel. In this new video series, I'm going to teach you the most important concepts required to crack embedded systems, system software roles at companies like Qualcomm, NVIDIA, Texas Instruments, Intel, AMD, and many others. Every day, we'll take few job-oriented concepts, few coding problems, hardware and OS topics, gradually build the strong foundation for these companies. Today's session is the first episode, and we'll start by understanding what skills these companies expect and how we are going to cover them step by step. Yeah, so let's start by looking at a JD and let's break it down what these companies actually look for. So first, they need a strong C++ programming background. What that actually means is you need to understand pointers deeply. So you need to be aware of using pointers, manipulating memory, how to talk to registers. That's something that you need to be uh, knowledgeable in. You need to know about memory layout. Memory layout is one thing, structures, unions, and most importantly, bitwise operations also you need to be aware of. So these are that's the first requirement. Second thing is you need to be knowledgeable about hardware and device drivers. Companies want people who can like talk to registers, hardware registers, as I pointed out. You need to understand interrupts, ISRs, and uh, need to know. Let me go down. Yeah. You need to know some communication protocols like SPI, I2C, WART, and protocol, so and PCIe. So if you are aware of these protocols, it will be advantageous for you. Uh, that's going to be working for you in embedded Linux drivers field. Uh, Next is operating systems. You need to have good operating system concepts. So for that, you need to know how processes work, what are threads, how they work, scheduling, virtual memory concept. Virtual memory concept you need to be aware of, paging. All these OS concepts are also very much required in this field. Next is little bit of, if you are familiar with Linux, it will be advantageous. You need to make yourself comfortable with shell, GDB, and Git and version controlling if you are aware of. That is a plus point. Cross compiling, that's another topic. Next, networking fundamentals are uh, kind of optional, but yeah, you can try them as well if you have time. TCP, UDP, uh, Ethernet, all these things you need to be uh, you can learn them as well if you are going for it. Next, virtualization technique. In this particular JD, it was uh, mentioned that you need to know the basics of a simulation tool, EMU, KVM. So we'll cover all these in detail in this in our video series. Okay, let's start with a basic task. Uh, First, you need to know how data is stored in memory and how you can access it. This will be very helpful in developing your OS concepts and learning about embedded firmware and software, system software in general. So let's start with a basic program of swapping values using reference and pointers. So this method will swap the values in place. You won't have to create extra memory for that. So you can try it yourself. You can try making two functions. They can take these variables A and B and exchange their values. Uh, you can pause this video and start. Uh, Otherwise, we can just jump into it. So let's make a program, swap ref. It will take these variables A and B. So this is passed by reference. It will these X and Y will be aliases. You can say different name to the same variable. So X here will denote A and Y here will denote B. They are not actually pointing to A and B. That's That's a different thing. So keep that in mind. What you can do, you can create a temporary variable and you can store the value of x here. Next, you can store the value of y in x. And finally, you can store the value of original x that was stored in temporary back in y. And that's how you did that in place. You didn't require to create any extra memory. You just referenced these uh, variables and you exchanged them. Let's see how we can do it using pointer approach. Later, I'll show you diagrammatically also how this is happening. First, let's, for the sake of it, let's make a program. Again, same thing. Temp we can, here we can't give x directly. Since x is a pointer, we need to dereference it. So we are dereferencing it here by using star x or asterisk x. And similar way, you can put the value of y in x. And next, you can put the value of m in y. So let me show you pictorially how it is working. So let's say you have these variables a and v. Uh, so if you pass it by reference, like we did here, we can, it will just ampersand x here means x is a alias to the variable. This is another name. You can refer this variable. Let's say this variable has this value 10. So x in our program will refer to this particular variable a with a value 10. Similarly, I also will refer. Actually, this will not point to it, uh, so don't get confused. It is just another name for b. So it's better I don't use this pointing thing. Yeah, and how it is different from pointer. Pointer actually stores the address of the variable. So let's say this variable, if it is a 64-bit machine, it will be stored in, it will have 8 bytes of address value. So let's say it is stored in some 00001111, and the B is stored in again some a random address B2500100. And so X and Y here, what we are using here, will be pointing to this variable A and B. These are pointing to this variable. What does it mean? That X will contain this address. X will contain this, the value of X will be this address. So it is different from reference in that the X is another name for A, but here X is containing value, uh, that of an address here. So similarly, Y also is containing this value 0xb250000. So, and for getting the value through X, this value 10 through X, what you need to do, you need to dereference it. Then only you can get the value. And you simply print, if you print X, this will print, if you print asterisk X, X, it will print the value. If you simply print X, it will print this address. So this is an important distinction between pass by reference. And actually one thing here, uh, while passing through pointer, you need to give it like this. You need to give the address here, not the actual variable how we gave here. Yep. All right. Before we go further, just few things to keep in mind. Uh, References cannot be null. You have to initialize them every time. And while pointers, they can be null, and sometimes pointers are left dangling also. Let's say you have this pointer, it is not pointing to anything. The address, it is not storing any address. So maybe while in the execution of your program, the memory that was allocated here was freed somehow, and right now this pointer is pointing nowhere. So that's a dangling pointer. So that creates memory leaks kind of problem in your code. So that should be avoided. That's why pointers are more powerful than references, but they should be used in a safer way, and in a you have to be careful while using them. All right. Now let's take one more important C pointer question. Uh, in this question, let's reverse an array in place using pointers. This is a classic Qualcomm, NVIDIA, TI style up, like warm up problem, because it tests your fundamental and not your syntax actually, but your fundamentals. Okay, let's go to the problem. So given an array, reverse it in place using only pointers. Like you don't have to use extra array, extra memory, no fancy libraries, just pointer manipulation you have to do. So how will you approach it? You can try on your own once, and then you can watch the solution. So for that, let's say you create a function, a reverse array, that takes the array, that points to the array and its size. You have to take a pointer that is pointing to the beginning of the array, the starting element of the array, and also the ending element. Again, one more end pointer. So here, what we are doing is array is the starting point, and we are adding the size, and we are doing -1 since arrays in C and C++, it starts from 0 till n-1. It goes till the n elements are from 0 to n-1. They are indexed like that. So you will have the pointer. These are not actually index. These are actually pointing to the element of the array. This points to the end element, and this start points to the start element. Now you will create a loop. Start, when start is smaller than end, what you will do, you have to uh, exchange them, like how we did in the swap program. Same way you can do here. First you initialize a temporary variable and put the start element in that. Then you can change start with end, exchange start and end, and you can exchange. You can then store the value of temporary that you had taken start into that, and you can store that value in end. So now the first and last elements are swapped. Now what you will do, this is just for first and last element. Now you need to go forward. You need to move these pointers forward, this one forward, and this end backwards. So let's do it. So you'll do start plus plus and end minus minus. And that's how the program is done. Let me also maybe pictorially let me show you how this is working. Maybe you can think these two pointers as moving opposite, like in the same direction towards each other. Let's say this is start and this is end. Here is our array. Let's say we have first element 1, second 3, 5, 7, 8. Start is pointing here right now, and end is pointing here. Now, for the first iteration, what we are doing, we are exchanging 1 and 8. So this will become 8, and this will become 1. And here we are doing start plus plus and end minus minus. So end now will point here. Uh, it will stop pointing here. Yeah. Uh, and start will point here on the next element. Yeah. So that's how they are like moving towards each other. And as soon as start, it will go till start is lesser than end. So here at this point, start becomes equal to end. So the execution will stop here because we don't need to swap this value against any other value. and that's how you'll reverse an array in place using pointers. Also, things to keep in mind here, you need to know pointer arithmetic. So the thing is, let's say uh, we had this array. Again, let me draw it. So let's say it was 1 here, and let's say this address is 0x1111. And if we are doing start plus plus, if we are doing start plus plus here, then technically what it should, you would think that it will go 0x1112 because you are doing start plus plus. But this is pointer arithmetic. It won't behave like this. It will directly move according to the size this pointer is pointing to. Here the pointer is pointing to an integer. So if you are doing start plus plus, it is going to add an integer uh, size to the present address. So let's say if you're doing start plus plus, it will become 0x1111 plus 4. So it will point to 0x1115. That is this address. Since arrays are stored contiguously in the memory, so this address here will be, uh, the next address will be just adjacent to the your first stored element. So this address here will point to the second element. So this thing you have to keep in mind about pointer arithmetic, and you don't need to keep track of it manually. The compiler does it for you. So the pointer arithmetic is little bit uh, tricky, so you have to just keep that in mind. All right. So this wraps up for our array reversal problem. In our upcoming episodes, we'll build on these pointer fundamentals and apply them to linked list, dynamic memory, and DMA buffers. Okay, so now you have seen how we can manipulate the data in memory addresses using pointers. Till now, we have done it on integers, the operations we had done on integers. So let's uh, do a problem on string as well and see how pointers can fit in there. Let's say we have a problem here. Given a string, we have to reverse it in place without using any extra memory. So there are multiple ways that you can do it. Uh, I would prefer the pointer way. So, and even in interviews, they might ask you by using pointers that you have to do it. So what you will do is, let's say you have one string, hello, HELLO, and one more null character will be there to mark the end of the string, and you have to reverse it like this. The O will come here, LLEH, and again the null character. Then how should you approach this problem? Uh, First, what you can do is you can start by uh, getting a pointer that points to the first element. Let's say char pointer start, and we keep. Let's say our string is char star s. Uh, that points to our string. S points to our string. So we'll initialize start with s, and then an end pointer to point to the uh, uh, last character of the string. So how we can do that? We can use s. We can do pointer arithmetic, how I told in the previous problem. You can calculate the length of the string and do -1. So what it will do, it will add to the current address. This is the uh, initial address. It will add according to the length of the string, and we are doing -1 to remove the null pointer pointing to the null character. So this end will point to O. Now simply we can write a while loop from start. The start should be smaller than end, and you can simply use a temp variable to store the start value, and in the start value you can store the end, and in the end you can again store temp. So that's how you swap these value one by one till uh, start becomes equal to end. Then the while loop will stop, And how do you make sure that it keeps on doing it? That in your while loop, you have to do start plus plus and end minus minus. So let's write this code once. Let me erase this. Yeah. So how we can do it is, let's say we have void reverse our function. This is a pointer that points to our string that is passed to this function. We can have a start pointer that points to the starting element, and an end pointer that will point to the end element. This strlen will give you the size of the string. You can do a -1 to point to the last element. Next, you can write a while loop where start is smaller than end. Again, now putting the value of end in start. You should remember how to dereference. To get the value, you need to dereference the pointer. Then only you will be able to get the value. So adding star uh, to the pointer name will dereference it. So again, and will be storing the value of temp. And now to continue the loop, we have to do start plus plus and end minus minus. Done. So that's how you're going to apply the pointer approach to strings as well. So till now we have seen some basic pointer questions. Let's make it a little more complex and interesting. So let's say we have to start with this new question, checking endianness of a machine. But before that, you need to learn two concepts. One is memory layout and other is typecasting. So you need to be aware of how actually the data is stored in memory so that you will be able to uh, actually manipulate the data better and actually know the endianness of a machine and what does it mean. Yeah, so to understand the memory layout, let's have one integer x equals to 1. Now, how will we represent this x in hexadecimal? Uh, let's say we want to represent it. So in hexadecimal, these two places will represent 1 byte. So 00000001. So this is our number. This is in a 32-bit machine. And in my earlier explanations also, wherever I mentioned a 64-bit machine, it was wrong. That was the addresses that I presented were based on a 32-bit machine. So since we have 1 byte uh, here for two places, and in total we have 4 bytes. So that means 4 into 8 equals to 32-bit. So this is 32-bit data. So how it will get stored in a, let's say we have a memory space here, 1, 2, 3. So where it will get stored, where this byte will get stored, will decide the NDNS. We'll discuss it later. First, let's say we have address of this byte, of this particular byte. Let's say its address is 00000100. So this 32-bit address is pointing to this this one byte, and the next byte will be pointed to by uh, address 00000101. So it just incremented by 1 since this is a contiguous block of memory, and each integer in a 32-bit machine is having 4 bytes. So it will be stored like this. So in the next address will be 00000102. All the zeros and 102. It increased by 1. Then again 0x 0000103. So that's how the address will be, the bytes will be addressed in the machine. Let me separate it. Yeah, maybe it will make it a bit more clear. So these are increased. So from 0, it is increasing till 3. So total 4 bytes are addressed. So this is integer x. Integer x is of 4 bytes. So, and maybe if you want to do let's say to the left side of it, it will keep on increasing, but that data will be there for some other variables or other uh, program or code or anything can be there. But we are right now concerned about our integer x. So this is the contiguous block of memory for x. And let's now discuss like the big endian and little endian. So this LSB here, this is our LSB, and this is our MSB, the least significant byte and the most significant byte. So if this least significant byte is stored in the lowest address, this is the lowest address here. So if this lowest address, if this LSB is stored, let's say 01, then 000000, then it becomes little endian. And vice versa. Let's say if this, let's say if this MSB, this MSB is stored here in the lowest address. Okay, you select the pen correctly. Yeah. If the MSB is stored here, let's say 00, and this LSB comes here, then it becomes big endian. That's the only difference. So the LSB stored in lowest address, that becomes little endian, and the MSB stored in lowest address, that becomes big endian. So that's the distinction between them. So for that, you have seen the memory layout, like how the address is increasing and how our uh, integer is getting stored here. But now the main part is how to, let's say you do some pointer arithmetic. Let's say uh, you want a pointer, let's say integer pointer p. You want this pointer to point to this address, to this uh, value x. So what you will do, you will write it like this. So you want this pointer to point to x, but when you do pointer arithmetic to that, so what the machine will do, it won't. Uh, right now, this pointer stores this address, this lowest address. It won't increase it by just one, since this pointer is of integer type. So it won't increase it by one. It won't. If you do a plus p plus one, it won't become 0x000 one dot 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 102. It won't become like that. Instead, what it will do, it will become 0x0000104. It will add, like how we discussed in the pointer arithmetic, it will add size of integer, size of the type of pointer it is, will add to the current address, whatever current address you are there, it will add that. So that won't work for our program because we want to check each byte. First, we'll check this byte, this, then this, then this, then this. And how do we do that? For that, we need to assign a character pointer. We need to have a character pointer because character pointer is of 1 byte, while integer pointer will be of 4 bytes. So it will be easy for us to manipulate with this. We can, if we do p plus 1 here, it will actually go to the next byte. It will address to the next byte. So it will actually become 102. So that's where the typecasting will come into picture. So how do we do that? Let's say we have a character pointer p equals to, uh, we can have what this statement is doing is, let's say we have this, this represents the address of x. We are taking the address of x and typecasting. This is typecasting. We are typecasting into a character pointer. So we have this address 0x0010, 1, and we are actually, if this was not present here, then it would be a integer. It will naturally it should go to an integer pointer. But right now, what we are doing is we are typecasting into it into a character pointer. So it can go. It can you can equate it to a character pointer. So uh, that's how you can take this address here, ampersand x. That will give you the address of the integer, and you can have a pointer e that will point to it. And when you do, and this pointer is a character pointer. And when you do p+1, it will actually move to the uh, move to the next byte available. So first was x was the lowest address was having 0, 1, let's say. So that will depend on the endianness, whether it is having 0, 1 or 0, 0. That we need to check with our program. We'll write it. And next byte we can check whether it is what that byte is just by doing p+1. So now that's in place, we can write a program and we can see whether how to find this endianness. Okay, so let's write the program now. Uh, it, we have, let's start writing. Let's say we have a function that will return an integer and that is checking the endianness of the machine. Uh, like before, we are taking one integer, int x equals to 1. Okay. So if we have this, let's say we have this integer x, then we will have a character pointer c that will point to the address of this integer x. Now, like we discussed earlier, I forgot to typecast it. You need to typecast it according to character point. Since x is an integer here, we are typecasting it to a character pointer so that c can point to it. C is a character kind of pointer, so it will point to x now. Now we are going to return 1 or 0 based on our this condition. Let's say we are dereferencing c, and if it is equal to 1, we are returning 1. If it is not equal to 1, we are returning 0. What does it mean? Let's say if we returned 1, uh, in our main program, we can check if 1 is returned, that means we can declare our machine to be little endian. And if, let's say, 0 is returned, that means it is big endian. So how it is working here, let me again explain it to you. Yeah. So we have this, our integer x here. Let's say the machine is little endian. So the least significant byte will go to the lowest address. Others are 0. Now we are having a character pointer c that is pointing to the lowest address right now. And if you do, if you are uh, checking the contents of C right now is having the address that we discussed, let's say the same address 101. C is having the lowest address right now, and it is pointing to the this byte. And if we are dereferencing C, that means we are checking its value. It will come 1, since the machine is little endian and it is storing the lowest significant byte. So if it is 1, then we are sure that it is little endian. Let's say if the machine was big endian, then what would be the case? This here would have been 0, 0, and this here would have been 0, 1. So now if you were to dereference C, you will get 0, 0, and your machine turns out to be big endian. So that's how this whole program is working. It's very neat and small program, but the concept behind is a little bit uh, not complex. But yeah, you need to be aware of memory layout, memory layout, pointers, and typecasting. So these things you need to be aware of to write this kind of program. So right in this video, we have learned about pointers, typecasting, memory layout, strings we have manipulated arrays, and we have checked the endianness of a machine. Next in our video, we are going to similarly have C programs. Let me write it down. We are going to have C programs, hardware concepts, like we did in this one, memory layout. Next one, I'm planning we can have some OS concepts also, OS concepts, or uh, like some keywords, like what are volatile keywords, some hardware concepts, ISRs, interrupts. These things also we can discuss in our upcoming videos. And I'm also planning to start a series for C++. Uh, that I will just do programming, not actually explaining the uh, all the stuff behind it like I did here. I'll be just solving problems, uh, maybe lead code problems we are going to solve here. But this here will be our uh, map, our plan to get a embedded, or let's say systems software job. So stay tuned and follow for more. Thanks.